Hi guys, let's talk about measurement. So to start off with, volume. Volume is going to be how much space something takes up. We're going to use, so we're talking about liquid volume first, okay? We're going to be using milliliters or liters to measure liquid volume. We can do it with a beaker, but a graduated cylinder is going to be better because it's more precise, right? We've got more little lines on it. A beaker typically only goes by 50s, and so that's not very accurate, okay? So a graduated cylinder is going to be more exact. That's what we want to use to measure liquid volume in milliliters or liters. Now, we can also do volume of a solid, right? If it's something like a regular shaped object, we can do length times width times height. But that's something else, right? That's like a little bit of math that we have to do. I'll talk about volume a little bit more in a second. Mass is going to be how much matter something has, right? How much matter something contains. And we use grams or kilograms for mass. We can use a triple beam balance to measure mass, or we can also use a scale. We're going to more than likely use a digital scale to measure mass because it's just a little bit better, and our triple beam balances are not that accurate. They're kind of broken, okay? Weight is going to be decided by two things, mass and gravity, right? This is why weight changes if you go to a different planet, right? Or if you go to the moon, you're going to weigh less because the moon has less gravity, okay? Weight is going to be used, we're going to use a spring scale to measure weight, and it's going to be measured in newtons, okay? So let's look at the questions that you have right here. What tool would we use to measure each item? The mass of an apple. Well, mass is going to be grams or kilograms, right? And we're going to use either a triple beam balance or a scale to measure mass. The weight of an apple, weight has to do with gravity, right? So we're going to use a spring scale. And then the volume of a glass of water, water is a liquid, so we're going to use a graduated cylinder for that. Now let's talk about displacement. When we want to find the volume of an irregularly shaped object, something that's a solid, we can use displacement, okay? So let's talk about Archimedes, right? Archimedes was tasked with finding out if the king's crowns were made of gold. And so he figured out that he could use density to determine if the crown was made of gold or if it was made of some other sort of metal. So in order to calculate density of the crowns, he had to have mass and he had to have volume, right? Mass was no big deal because he could find the mass of the crowns, but the volume of the crowns was a little bit different because he could not do length times width times height, right? Because of their shape, and he could not melt them down into a liquid because they were already crowns, right? The king didn't want him to do that. So what did he do? He ended up having to use displacement to find the volume of the crowns. And this is basically immersing an object in water and seeing how much the water rises, right? So if you take a graduated cylinder and put some water in it, and you measure where that water level is at, and then drop in an irregularly shaped object, like a crown or a rock, or anything that you cannot do length times width times height with, right? The water is going to move up. And so if you look at the before and the after and you subtract them, then that gives you the volume of the irregularly shaped object. And so Archimedes was able to use that volume, right? Do mass divided by volume, find the density of the crowns, and determine if the crowns were made of gold or not. And it turns out that they were not, okay? So that is volume by displacement. The water is getting displaced. It's moving out of the way. And if we measure that displacement, it's going to give us the volume of the irregularly shaped object, okay? So just remember, after minus before gives you the volume of the object. So let's talk about how to read this stuff, right? We have a graduated cylinder here. When we look at the water level or whatever liquid, right, we always look at the bottom of the meniscus. So here at the bottom of the U, and we go across from here. And then the only other thing left to do is to figure out how much each line is worth, right? In this case, each line is worth 1 milliliter, right? So I have 10 here, 11, 12, 13, 14, 15 milliliters of whatever liquid is here. Here's a thermometer, very similar. right? I just have to figure out how much is each line worth and then read off where whatever temperature it's telling me, right? And because this is science, we're going to be using metric. We use Celsius. So this is what you're going to glue into your composition notebook, right? Into your science journal. You are going to have several different, we've got 5 different tools here, and you are going to determine what they are used for, what unit we use with that tool, right? The name of it, the definition, and all of that stuff. So let me show you what it should look like in your journal. This is your journal. So you are going to have the 5 different types of measurements that we need to do, right? And then you're going to glue in the definition, the tool, like the name of the tool, a picture of that tool, and then whatever unit we use for that tool, okay? And this is going to help you out a lot when we do our measurement lab. So let's take a look at what it should look like. So here you have all of your definitions, okay, for each of the different types of measurements, which I just went over. You have the name of the tool, you have a picture of your tools, and then you have the unit that goes along with that tool, okay? So make sure that your journal looks like this. If you have any questions, please let me know. Thanks.